Good morning to all. Today we will going to start the subject engineering mechanics, and we will see how the engineering mechanics is useful in solving the problems, especially in the field of mechanical engineering. So let's start with the engineering mechanics. Engineering mechanics is the branch of science which deals with the bodies which are in motion or which are in rest. So according to the state of the body, we can further divide engineering mechanics into two parts. One is statics and second one is dynamics. As I earlier mentioned, like engineering mechanics is nothing but the branch of science which deals with the bodies which are in rest or in motion. So we have two different kinds of states of body. First, the body will be in rest, and second one, the body will be in motion. So in the branch of engineering mechanics which deals with the bodies are in rest, that is called statics. So statics is nothing but the branch of engineering mechanics in which we are interested in the bodies which are in rest. Similarly, the dynamics is nothing but the another branch of engineering mechanics which deals with the bodies which are in motion. So these are the main classification of engineering mechanics, that is statics and dynamics. But in case of dynamics, of course, the bodies are in motion, but how we are going to analyze the bodies which are in motion? For, as we know, the forces or couples which are responsible for motion. Sometimes we are considering the forces or couples for analyzing the bodies which are in motion, and sometimes we are not considering the forces and the couples which are responsible for motion. So on the basis of that, we can further divide dynamics into two parts, that is kinematics and second one is kinetics. In kinematics, we are not consider forces or couples which are responsible for motion. So in kinematics, don't consider forces and couples responsible responsible for motion. But in case of kinetics, we have to consider forces and couples responsible for motion. So consider forces and couples responsible for motion. So this is the brief idea about engineering mechanics. What are the branches of engineering mechanics and how we can classify dynamics also in terms of kinematics and kinetics, which depends whether we are considering forces or couple responsible for motion or we are not considering forces or couples which are responsible for motion. So before going into the detailed things which involved in the engineering mechanics, let's start with the simple things which is very important in engineering mechanics is force. In daily life, we are using the word so many times in each and every activity. Means we are applying force here on the our door. We are applying force to opening the window. So there are so many examples in our daily life where we are using the force. But how we can define the force? So in a general sense, we can say that push or pull. It is nothing but a kind of push or pull. So, or on the basis of the effect of the forces also we can define. It means like if the body is in motion or body is in rest. So for changing the state of the body, we require some external agent. So this external agent is nothing but force. So we can define the force is nothing but an external agent which is responsible, for changing the state of body, changing the state of body. It may be state of rest or state of motion. State of motion. So by this way we can easily define the term force. So in defining the force, basically we required magnitude, we required direction, we required point of application, and we required line of application. Because the force is nothing but a vector quantity, and for defining any vector quantity these things are required, especially magnitude and direction. But we are also interested in where we are applying the force and in which line we are applying the force. So we are also interested in point of application and the line of application. So now let's discuss about force system. So as we see the name force system, it means large number of forces acting on a body is called force system. It's called force system. In other words, means if a large number of forces are acting on a body, then this system is called force system. Let's take an example. Suppose on body we are having the force F1, F2, F3, F4 and F5. All these forces are acting on a body. So we can say that this figure is nothing but a force system. We can say that it's nothing but a force system. So now we can say that force system is nothing but a large number of forces are acting on a body. So this combined system we can call force system. So there are a various kind of classification in force system. One by one we will take each classification, and let's start with the classification of force system. So we can divide the force system in collinear force system. We have coplanar force system and non-coplanar force system. Means if we talk about collinear force system, the name itself defines the line of action of all the forces will be passing through the same line. Means all line of action of the forces will be passing through same line. That is called collinear force. Suppose we are having force F1, F2, F3, F4, F5, F6, F7, F8 and so on. If we see the line of action of all these forces which is passing through the same line, so this kind of force system we can say that collinear force system. And the very good example for collinear force system is tug of war. Tug of war is a very good example of collinear force system in which the line of action of the force applied by the member of each team will be on the along the rope, means will be on the same line of action. So we can say that the tug of war is a very good example of collinear force system. Similarly, coplanar force system means all the forces will be in the same plane. Suppose I am drawing the forces like suppose F1, F2, F3, F4 and F5, F6, F7 and so on. I am drawing in the plane of paper, suppose in XY plane. So I can say that the force from F1 to F7, all these are in the same plane. So I I can say force system is coplanar force system. Similarly, if the line of action of all the forces will be in different plane, then we can say that it is non-coplanar force system. Suppose if I talk about this kind of force system, then we can say that some of the forces are lying in xy plane, some of the forces are lying in xg plane. So these all these forces are not in a single plane, these are in different planes. So we can say that it is an example of non-coplanar force system. So in coplanar force system we are having parallel forces, we are having concurrent forces, and we are having non-concurrent forces. Means in coplanar force system, according to the line of action of the forces, we can further divide the force system into parallel force system, in which the line of action of all the forces will be parallel to each other. This is a co-parallel forces. Means the very good example of parallel forces, the weight of students standing in a row, standing in a row is a very good example of coplanar parallel forces. Similarly, the concurrent forces, coplanar concurrent forces means the line of action of all the forces will be in the same plane and it will pass through a single point. Suppose this F1, F2, F3. All these forces are in a plane and they are passing through a single point. So we can say that this F1, F2, F3 are concurrent forces. Suppose if we take an example of a electric bulb which is hanging by this manner, it's an example of coplanar concurrent forces, because if we see the forces acting on electric bulb, that is mg, from this rope there is a tension T1 and T2. So this is all these forces T1, T2 and mg is passing through a point O. So we can say that it is a coplanar concurrent forces. Similarly, the coplanar non-concurrent forces means the line of action of all the force will be in single plane, but it will not pass through a single point. So all these forces F1, F2, F3, F4 and F5 are lying in the same plane, but line of action of all these forces are not passing through a single point. That's why they are calling coplanar non-concurrent forces. Very good example is seesaw. In seesaw, the two person will be sitting like that and there will be a hinge. So if we take and weight of this person and the hinge reaction, then we can say that all the three forces will be in a single plane, but the line of action is not passing through the same point. So that's why it is calling coplanar non-concurrent forces. Similarly, for non-coplanar force system, we can further divide by same thing like parallel forces and concurrent forces and non-concurrent forces. In non-coplanar parallel forces, all the forces will be in different planes, but they will be parallel to each other. The best example for defining the non-coplanar parallel forces like passengers standing on railway platform. or we can say that weight of passengers standing on railway platform is a very good example of non-coplanar parallel forces. Similarly, non-coplanar concurrent forces means all the forces will be in different plane but they will pass through a single point. So very good example is tripod carrying camera. Similarly, the last one, that is non-coplanar, non-concurrent forces, means all the forces will lie in a different plane and their line of action will not pass through a single point. Very good example is forces acting on aircraft. It's a very good example of non-coplanar, non-concurrent forces. So we have already defined the force system and what are the classification of this force system. So we can easily visualize the different force system and we can easily say this one is coplanar force system, this one is non-coplanar force system, this is co-linear force system. So it was all about force system. Now start with the equivalent force, or we can say that resultant force. As we already seen in force system, a large number of forces are acting on a body. But every time we are interested in the effect of these forces on a body. So if it is possible for us to find a equivalent force which can replace all the forces and which will produce the same effect as produced by all other forces, then this force we can say that it is a equivalent force or resultant force. Let's take an example of a force system. I am drawing the coplanar concurrent force system. Here I am having uh, forces F1, F2, F3, F4, F5 and F6 are acting on a body. And now I have to find the equivalent force or resultant force. So as the definition of equivalent force or resultant force or equivalent force is nothing but a single force which can replace all the forces F1, F2, F3, F4, F5, F6 and which will produce the same effect as produced by F1 to F6 forces. So we can say that resultant, that is R, is nothing but a single force which can replace all the forces like F1, F2, F3, F4, F5, F6 and which will produce the same effect on a body as produced by all these forces. So for if we are having the resultant R or equivalent force R, then we can easily solve the problem and we can find our solutions very easily. So now our objective is how to find R. So now our objective is how to find R, or we can say that resultant force. So here we are interested in 2D problems. So for 2D problems, basically we are interested in coplanar forces. So we are interested in coplanar forces. So in coplanar forces, we have two categories: coplanar concurrent forces and coplanar non-concurrent forces. Coplanar non-concurrent forces. So for these two kinds of system of forces, we have to find the resultant R. So let's take an example of coplanar concurrent forces. So I would like to draw the force system that is coplanar concurrent forces. Suppose this one is coplanar concurrent forces. All the line of action of all forces are in a single plane and it is passing through a single point, suppose O. And now we have to find out the resultant R. So basically there are two methods. One is graphical method and second one is analytical method. In graphical method for this coplanar coplanar concurrent forces, we are having triangle law of forces and polygon law of forces. I am not going into the much detail of this graphical method because the graphical method with the help of graph we can solve it. But in our GET examination we want accurate results. So we can get accurate results only by the analytical methods because graphical methods use graphs and the chances of manual error will be more. So the result will vary from student to student. So we will not concentrate on the graphical method, but for our knowledge, I am just explaining these are the two graphical methods for the coplanar concurrent forces. So now talk about how we can solve the coplanar concurrent force system for finding the resultant force. So analytical method. What we have to do? In analytical method, we are interested in coplanar forces. So our coordinate axis is like that. This is x and y. So the first step for solving the problems by the analytical method, find components of all the forces about x-axis and y-axis. Second, find algebraic summation of all the force components about x-axis and y-axis. Third one, use r equals to sigma fx square. Summation of fx square is nothing but the algebraic summation of components of all the force about x-axis plus summation of fy square. Summation of fy is nothing but the algebraic summation of components of forces about y-axis. Fourth one, direction denoted by theta is nothing but tan inverse of sigma fy summation of fx. So by this way we can find out the direction also. But one more important thing in defining the force, we have magnitude, direction, and now we want to know what will be the point of application. So fifth one will be the point of application. So in coplanar concurrent forces system, the point of application will be the same as all the forces like F1, F2, F3 and F4 are acting on the point O. So the point of application will be same as all forces means where the all forces are acting on the same point, the resultant will also act on the same point in case of coplanar concurrent system of forces. Now let's talk about coplanar non current force system. How to find R for that? How to find resultant for this system? Similarly, there will be two methods. One is graphical and second one is analytical. So for coplanar non-concurrent force system, the graphical method is funicular polygon law of forces. So this one is the graphical method used for coplanar non-concurrent force system. I want to mention one thing. If we are interested in R and if we going from coplanar concurrent forces to the non-concurrent force system, everything will be same. But in case of concurrent force system, the point of application will be the same where all the forces are already acting on the body. But in case of coplanar non-concurrent force system, the point of application of the resultant force we have to find out with some other method. That's why the same graphical method we can't use here. So that's why we are using the funicular polygon law of forces for coplanar non-concurrent force system. The analytical method for finding the R will be same. Like first we have to find out the algebraic summation of all the forces about x-axis, because in 2D problems we are having two axes generally, x and y. Similarly, we have to find out algebraic summation of all the forces or component of forces about y-axis. I am saying the algebraic summation because force is a vector quantity, so we have to think about direction also. Third one, we have to use the equation R equals to square root of summation of fx square plus summation of fy square. And for direction, we can use this equation theta equals to tan inverse of summation of fy summation of fx. So these four steps, 1, 2, 3, 4, is same in coplanar concurrent force system or coplanar non-concurrent force system for finding out R and theta. But for point of application, in case of coplanar non-concurrent force system, we have to use Varignon theorem. Varignon's theorem. So let's talk about Varignon's theorem. So before starting the Varignon theorem, first I will draw the coplanar non-concurrent force system. Suppose F1, F2, F3 and F4. These are the four forces are acting on a body. And now we have to find out first the resultant R and then the point of application. So resultant R we can easily find with the step 1 to 4, but the point of application we have to find out with Varignon theorem. So Varignon theorem is saying the moment about any point due to resultant R is equals to algebraic summation of moments of all the forces about the same point. So according to Varignon theorem, moment about any point due to resultant R equals to algebraic summation of moments of all the forces about the same point. By this way we can easily find out the point of application or location of the resultant force. Let's take an example. Suppose the resultant force is lying here R. I'm just assuming. So I am interested in distance x, where it is lying. Suppose this one is the point A. So according to the Varignon's theorem, moment about any point due to resultant R. So moment of resultant R at this point A, we can easily write down it is nothing but R into perpendicular distance, that is x. And suppose we have to define the direction. So moment due to this R about A will be in clockwise direction. Suppose it is positive, and for our understanding the anti-clockwise will be negative. So it should be equals to algebraic summation of moments of all the force about same point. Suppose by F1 moment here at A it will be F1 into 0 because perpendicular distance is 0 plus F2, suppose this distance is 1 meter, so it will be 1 plus due to F3 into 1 plus 1 it will be 2 plus suppose for F4 into 3. So X will be F2 plus twice F3 plus thrice F4 divided by R. So by this expression we can easily find out X or point of application of the resultant. So I think now it's clear with the help of Varignon theorem, in case of coplanar non-concurrent force system, we can easily find out the point of application of the force. So graphically, with the help of funicular polygon law of forces, we can easily find out the point of application of resultant force in case of coplanar non-concurrent force system.